All right, so next we're going to do 6.2 and 6.3, and actually I'm going to start talking about orthogonal projections, and within that discussion we'll bring up orthogonal complements. So let's start with orthogonal projections. All right, what does that mean? All right, so we're going to start by looking at a picture and we're going to project a vector onto another one. So let's project a vector y onto a vector u. So what does that look like? So let's say we have some vector u and another vector y. I'm actually going to draw y a little longer. It could be shorter, it could be the same size, it doesn't matter. This is our vector y. And when we say we want to project y onto u, we're going to take this vector y and rotate it down so that it lays flat on top of u. And that is going to be our projection. So if you take this vector y and place it exactly on top of u, yes, it's going to be a little longer. It's going to be in the exact direction and have the exact same length. This is not exact, but the exact same length as y. So all of this together, I'm going to call it y hat. That's a y. All right, so off to the side, take some notes here. Y hat is the projection of the vector y onto the vector u. So we took y, laid it down, that's y hat. All right, so what we want to do in this lecture is figure out how to come up with a formula for y hat. So if we know what y and u are, could we write y hat in terms of these two vectors we already know? So we want to find y hat in terms of y and u. So that's going to be our goal for this video. Okay, so let's get a starting point. What do we already know? We already know y hat is going to be in the same direction as u, but also it's just scaled. It's the same as u, just a little longer, or it could be a little shorter. So really, y hat is just going to be some scalar times u each time. For some scalar c. So we already have the beginnings of a formula here. So all we have to do is figure out what this c is. All right, so we can do that. All right, so I am actually going to draw an extra vector here, and that's going to help us. I'm going to draw the vector connecting the tip of y hat to y. So I'm going to go from here to here. And in 2D, this makes a right angle. In other dimensions, it means these two vectors will be orthogonal. So I'm going to call this vector z. All right, so how does z fit in with everything else? Here's a little note. If you take y hat, our projection, and add z, we get to our vector y. So y hat plus z is the vector y. So that means I can figure out what z is. Right, I can solve for z. It's going to be y minus y hat. But we already came up with a new way to write y hat up here. Y hat is the same as c times u. All right, so that's one thing we know. We know that z is y minus cu, but also we know that u and z are going to be orthogonal. All right, so if u and z are orthogonal, we know exactly what we can set up. When you dot product these together, we should get 0. So 0 should be u dot z. And we've already come up with an equation for z. Z is y minus cu. So 0 also equals u dot product with y minus cu. So let's actually do this dot product. So I'm going to distribute u dot y minus cu dot u. All right, so you have a long chain of math. Let's summarize the main part. The main part is 0 equals this, u dot y minus cu dot u. All right, so what is the point? Why are we even doing this? Remember, we want to find y hat in terms of y and u, and we've already decided that y hat is cu, so we just need to figure out what c is. We now have an equation that has c, so we can solve for c here. So what I'm going to do is move this part to the other side. And then we can divide, and then we'll have c. So c is u dot y divided by u dot u. Okay? All right, so now we're able to fulfill our goal, come up with an equation for y hat in terms of u and y. We said that y hat is c times u. Now we know what c is. So y hat is our c, which is this, u dot y divided by u dot u times u. So this is regular multiplication, not dot product. So times u. And this is what's known as the projection of y onto u. So you may see this denoted as PROJ with the subscript of our vector u. Inside we have y. So the projection of y onto u, or the projection onto u of y. All right, so here's how we would say it in words. The projection of y onto u. So if you're asked to find the projection of one vector onto another, this is the formula for that. And so in the next video, we're going to talk about how to project onto a subspace.